Hi, everyone. Today we're going to talk about trigonometry and specifically right triangle trigonometry. Some of this is going to be review, things that you did in geometry, but I know that's been a little while. So, first of all, let's talk about the anatomy of a right triangle. When we look at a right triangle, we of course have our right angle here, which makes this side across from it the hypotenuse. And the other two sides that make an L are the legs. Okay, so leg one, leg two. When we label a triangle, we have angle A here, which means that this side over here is side A. Notice we use a lowercase printed letter. This is angle B, so opposite that would be side B. And this is angle C, and opposite that would be side C. In the right angle, we have two acute angles, one right here and one right here. Theta is the eighth Greek letter, and it will represent an angle measure. So a lot of what we're going to be doing here is finding this angle measure based on the ratio of the sides in the right triangle, or using that angle measure in one side to try to find the length of another side. So you may recall sine, cosine, and tangent from geometry. You might remember SOHCAHTOA. Okay, so the sine of an angle is equal to the opposite length, so the length of the opposite side, divided by the length of the hypotenuse. The cosine of an angle is equal to the length of the adjacent side, divided by the hypotenuse. And the tangent of an angle is equal to the length of the opposite side, divided by the adjacent. And these sides are all going to be labeled based on whether we say angle A is theta or angle B is theta. Now, no matter what, when we're labeling our triangles, the hypotenuse is the hypotenuse. Like that's not going to change. But if we were to say that angle B was theta, this side right here would be adjacent to the angle, and this side right here would be opposite, right? Because adjacent kind of means attached or next to, and opposite means on the other side. If we switch that up and we used angle A as theta, those two sides would change because this would now be the side that's attached to the angle, and this side over here would be the opposite. So lots to think about here, lots to remember. We also have to remember good old Pythagorean theorem that a squared plus b squared equals c squared. Okay, we're going to be using that a lot. Okay, so what else do we know? Let me keep these here so we can see them. So what else we know is that we actually have other trig ratios that we're going to work with, and they are the reciprocals of the trig functions that we just used. So the reciprocal, remember reciprocal is when we take a fraction and we interchange the top and the bottom. So the reciprocal of sine is called cosecant, and we abbreviate it CSC. So the reciprocal of sine, so in other words, cosecant of theta, will be hypotenuse over opposite. Look, sine was opposite over hypotenuse. So cosecant, you just flip these two. The reciprocal of cosine is secant. So we say secant of theta is, and again, we interchange the numerator and denominator. So the secant of theta would be hypotenuse over adjacent. And this is an easy one. The reciprocal of tangent is cotangent. And again, we write the reciprocal. So cotangent of theta equals adjacent over opposite. Now, you're going to have to memorize these and memorize which ones go with which. I will give you a little trick. I think tangent and cotangent are easy ones to remember. But what I want you to remember is that each one has one that starts with a C. So the reciprocal of sine is cosecant, and that starts with a C. Cosine starts with a C, and its reciprocal is secant. Okay, and then of course tangent and cotangent. Those are never the tough ones. Okay, let's continue. I'm going to give you a lot of information here, and then we'll use it. So the inverse of our trig functions are usually used for calculating angles. And we will say arc sine or inverse sine. Okay, so for example, arc sine or inverse sine. Remember that an inverse undoes a function, right? It reverses it. So taking the inverse sine of something that already has a sine will undo it, and we'll get there in a little bit. So for cosine, we would say arc cosine, or of course, inverse cosine. And you've probably figured this one out. Arctan, I'm going to write the whole word, but we usually just say arctan or inverse tan. That one we shorten up when we say it. Okay, so arctan or inverse tan. So those are the reciprocals. Okay. Looking at the trig function, pretty simple. We can actually graph this, and this is going to be coming a little bit later, but we would have y or f of x equals the sine of x. Cosine, pretty simple, just looks like this, cosine of x. And tangents graph, if we were graphing these, which we will be, not yet, but we will be, looks like that, tangent of x. Okay, and I'm not going to worry about the inverse trig relation right now. Okay, so let's get to it. What I'm asking you to do here is to, let me get my pen, we'll go for blue. Okay, what I'm asking you to do here is calculate all 6 trig ratios for theta. So the first thing that I would tell you is that if theta is here, okay, no matter what, this is the hypotenuse, right? So I'm going to label that hypotenuse. And if this is theta, the side that's attached to it that's not the hypotenuse is the adjacent side. And the side on the opposite is the opposite side. Now, what you'll notice is we have not been given all 3 sides, have we? So we need to calculate the length of the third side. And that's where Pythagorean theorem comes into play. So 8 and 15 are the A and the B, and the C will always be the length of the hypotenuse. So we will have 8 squared plus 15 squared equals C squared. And we know to calculate C, we would have to undo squaring. So we'd be taking the inverse of that, which is to take the square root. So if you put that in your calculator, if you don't put the square root in, what you'll get is 161. So if you did 8 squared plus 15 squared, you will get 161. That can't be right. Hold on one second. Let me fix something. Okay, I had a little calculation error there. Sorry about that. You should get the square root of 289. And what's nice about that is 289 is a perfect square. So we can actually simplify this so that C equals 17. So that means our hypotenuse is 17, the adjacent side is 15, and the opposite side is 8. So what I want to see you do is I want you to write the sine of the angle equals, and give me the fraction. The cosine of the angle, so cosine of theta equals, give me the fraction. And tangent of the angle equals, and give me the fraction. And then I want you to give me the reciprocal functions. So remember I told you each one has a partner that's a c. So sine's reciprocal function is cosecant. Cosine's reciprocal is secant. People sometimes mess those two up. They want to switch them around. And then tangent's reciprocal function, easy peasy. It's cotangent. So cotangent of theta equals. So go ahead and see if you can do that. I'd like for you to pause the video and see if you can fill in these fractions. Okay, so this should have been pretty straightforward. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Oh, opposite over adjacent. So now for the reciprocal functions, we're just going to interchange the numerators and denominators. So cosecant would be 17 over 8, which is the hypotenuse over the opposite. The secant will be hypotenuse over adjacent. And cotangent will be adjacent over opposite. Okay, so here's what I want you to do. I want you to, right now on letter B, I want you to go ahead, use Pythagorean theorem to calculate the length of the missing side and leave it in exact radical form. We do not want decimal approximations. Okay, go for it. Let's see what you get. Okay, so using Pythagorean theorem, you should have gotten that A equals 3 root 3. Okay, and you could have taken some shortcuts. I wrote out every step. Okay, so we're squaring, we move the 3 squared over, we actually square those numbers, we get 27, we take the square root of 27, we get 9 and 3. 9 is the biggest perfect square that goes in, so we get 3 root 3. So this side right here is 3 root 3. So now what I want you to do is exactly the same thing that we just did, which is find all the trig ratios for this triangle and rationalize denominators when you can. Go ahead and do that. Stop the video. Okay, so I did some of them for you just so you can see. So sine would be opposite over hypotenuse and reduce the 3 and the 6. Cosine would have been adjacent over hypotenuse and of course reduce that. And tangent is opposite over adjacent and we reduce that. Now, when we write the reciprocals, we can basically take our values and just interchange the numerator and denominator. If we look at cosecant, we get 2 over root 3. And you know better than to leave an answer like that. So we have to rationalize. And what we get is 2 root 3 over 3. For secant, that's easy. Take the 1 over 2 and make it 2 over 1. Okay, which is just a plain old 2. And for tangent, we're going to write the reciprocal. It will be 1 over root 3. And then, of course, rationalize. And again, some of you may not have to write this step out because you just can kind of jump to the answer. I'm totally fine with that. That's what our answer will look like. Okay? All right, let's move along a little bit. What you are going to do, I didn't think I had 3 more. Okay. You're going to do these 3 problems, and I'm actually going to give you 3 more to do. So why don't you start doing those while I write in the new problems? Okay, you can pause this video. Okay, so I wonder how many of you are having trouble with this example. Okay, example 2. So let's take a look at it. It says, if cosine of theta equals 3 over 4, we have to find the secant of theta. Well, if you remember that cosine and secant are reciprocal functions, this is a really easy problem because all you have to do is write secant of theta equals 4 over 3, and you are done. Same thing here. Cosecant and sine are reciprocal functions. So all we have to say is that the sine of theta equals 1 over 1.345. Letter C might be a little tougher. So we know the sine of theta is 5 over 13, and we're being asked to find the cosine of theta. If you recall, cosine is adjacent over hypotenuse, which means we have to calculate the length of the adjacent side. we're going to sketch this triangle. Here's theta. So if we're taking the sine of theta, oh, obviously our right angle is there. If we're taking the sine of theta to be 5 over 13, that means the opposite side is 5 and the hypotenuse is 13. So what do you do when you have two sides of a right triangle and you need to calculate the third side? Sounds like Pythagorean theorem to me. So I'm going to give you a little shortcut here. If you write it like this, we've already moved the formula around a bit, okay? So we have the hypotenuse squared minus the other leg squared, and we undid taking the square root already, okay? So 13 squared is 169, 5 squared is 25. So what we get is the square root of 144. That's a value you should know. Okay, it's a perfect square, so not much breaking down there. What we find out is that the adjacent side is 12, which means the cosine of theta, now that we've calculated the adjacent side, we can write to be 12 over 13. Okay, so you're going to have some fun doing D, E, and F, which I've written there for you. And I think that's going to be the end of this video. Okay, so go ahead and do D, E, and F, and I will give you the answers in a little bit. Okay, so go ahead and do that. Okay, so I'm not showing you the work right now, but I'm giving you the answer so that hopefully you can make sure you're going in the right direction. For some of these, you will have to rationalize denominators. Some of these radicals can be broken down, some cannot. So check your answers, make sure you did everything right. And that's the end of the video. Have a great day, everybody.